Antarctica seems to be completely covered with ice. But take a look. Can you see those small ice-free areas? There, tiny life forms somehow manage to survive in harsh conditions. Our scientists try to figure out what they look like, what their role is in the ecosystem, and how climate change affects these bacterial communities.
We work in this remote area, the Sør Rondane mountains. And we are based in the Princess Elizabeth station. We first need to find these microbial communities. They can be found on Nunataks, steep rocky peaks that rise above the ice. For this, we use high-resolution satellite images to map the area and the DEM of the region. A DEM is a 3D representation of the terrain and is used to analyze its characteristics and exposure. Once we've selected interesting locations, we need to go there to find microbial mats and soil crusts. We not only collect physical samples, but also harvest environmental data. And for this we use eye buttons. Here I have one at real size. A microchip inside registers temperature and relative humidity every 3 hours. And we drop them at the chosen sites. Of course, we indicate precisely where we leave them, because they're not exactly easy to find, especially because we collect them after a whole year to read out the data. They are only one piece of the puzzle that will help us to understand how climate conditions impact microbial communities.
To know more about how these microscopic life forms react to climate fluctuations, the scientists install open-top chambers and snow fences. Open-top chambers are small greenhouse-like structures that increase the temperature and humidity and decrease the cold wind strength. Snow fences allow scientists to simulate the accumulation of snow due to global warming. It is normally too cold and too dry to have a lot of snow in the middle of the Antarctic continent.
We actually simulate climate change.
The researchers collect soil samples from the open-top chambers, from the snow fences, and also from similar locations that haven't been altered so they can be compared.
Of course, the sampling gear has to be sterile because we don't want to contaminate our samples with our own DNA and other organisms. But those latex gloves, well, they're not really a good protection against the cold.
Back in the lab, scientists extract the DNA to analyze and compare the genetic variations between the collected specimens. All the gathered information is put into giant databases that are freely and openly available for scientists all over the world.
It's only thanks to the combination of satellite remote sensing and local soil sampling that we can understand how climate change impacts these microbial communities.